We are now at question 2A of the CSEC Math January 2013 video solution, and we are given this to solve for P. So basically we want to make P the subject, and the first step here is to expand this bracketed term so we can isolate the terms in P. And so expanding the bracketed term gives 2 multiplied by P is 2P, and then 2 multiplied by 5 is 10. This minus 7 comes back here, and on this side we have 4P. And now the 10 minus 7 is equal to 3, and so this equation reduces to 2P plus 3 equals 4P. And what we can do now is subtract 2P from both sides, and so we'll end up with an expression in P being on one side of the equation. And this is it. We are subtracting 2P from both sides, and so it reduces to 3 left on this side being equal to 2P on this side. If we subtract 2P from this side, this 2P is eliminated, and if we subtract 2P from this side, we end up with 4P minus 2P, which is equal to 2P. And so now, to make P the subject, we simply divide both sides of this equation by 2. And so dividing by 2 gives P equals 3 divided by 2. 3 divided by 2 is 1.5. And so the answer here is P equals 1.5. Let's move down to part B of this question 2. And in part B, we're asked to factorize completely. Firstly, 25m squared minus 1. I see two terms here with a minus sign, so I'm thinking the difference of two squares. And in fact, it is the difference of two squares, because we have to remember that 1 is a perfect square of 1. 25 is the perfect square of 5, and we have m squared. So this expression can be written as the difference of two squares. And this is it. The 25m squared here can be written as 5m all squared. And as I said, 1 is the same as 1 squared. And now, when we apply the rule for the difference of two squares, we end up with 5m minus 1 multiplied by 5m plus 1. And that's it. We have factorized this expression completely using the difference of two squares. Let's move down to part 2. Now, part 2 gives us this quadratic expression. It's a quadratic in n. And so we have to apply the special method of factorizing a quadratic expression. And it involves converting this 3 terms expression into 4 terms by splitting this middle term. This is the middle term of this quadratic expression. And the process is sometimes referred to as splitting the middle term. In this case, the middle term is negative 3n. We have to remember to carry the sign of this middle term, negative 3n. Now the process involves firstly multiplying the two end coefficients, and we are carrying the sign all the time. So we multiply the two end coefficients of this quadratic expression, which is already in the standard form, and it is 2 multiplied by negative 20. This 2 multiplied by this negative 20 gives us this negative 40 right here. And what we want to do is find factors of this negative 40 that add to the negative 3 here. And so I circle this negative 40, and this means that we are trying to find factors of negative 40 that add to the negative 3 that is a coefficient of the middle term. And if you cannot identify those factors right away, the safe way to do it is to go down the list of factors of negative 40 and search for the ones that will add to negative 3. Now we must bear in mind that since we are searching for factors of a negative number, one of the factors will be positive and one will be negative. And since we want the sum of those two factors to be negative 3, it means that we must give the larger of the two factors of negative 40 the negative sign, because we want the sum to be a negative number. And so we try the first factors of negative 40, and remember we are giving the larger of the two factors the negative sign, and so the first factors to try would be 1 and negative 40. 1 and negative 40 are factors of negative 40 here, but when we add 1 and negative 40, the result is negative 39. And so that's not the result we are looking for. It is not negative 3, and so no, those are not the factors we are looking for. And so we move down. We say 2 and what? 2 and negative 20 are factors of negative 40. But when we add, the result is negative 18. And so no, again, we are searching for negative 3, and negative 18 is not negative 3. And so no, those are not the factors of negative 40 we are looking for. And so we move down again. 3 and what? 3 is not a perfect factor of negative 40. So we move down to 4. 4 and what? 4 and negative 10. 4 and negative 10 are factors of negative 40, but when we add 4 and negative 10, the result is negative 6. We are looking for negative 3. And so no, we have not yet found the factors we are looking for. Right? And so we have to move down again. So we go down to 5. 5 and what? 5 and negative 8. 5 and negative 8 are factors of negative 40, and when you add 5 and negative 8, the result is negative 3. So yes, that's what we are looking for. Factors of negative 40 that add to negative 3 are 5 and negative 8, and therefore we are going to split this negative 3n into 5n minus 8n. And this is it. Factors of negative 40 that add to negative 3 are 5 and negative 8, and therefore the expression becomes 2n squared from here. The negative 3n, we split it into plus 5n minus 8n, and the negative 20 comes back here. And now we have 4 terms, and we can proceed by factorizing by parts or factorizing by grouping in the normal way. And so we look for a common factor in the first 2 terms here, and in this case the common factor is n. The highest common factor, that is n. And when we factorize n out of these 2 terms, we end up with 2n plus 5 in the bracket here. And the safe thing to do is to put back the bracketed term on this side, because we're going to be factorizing these 2 terms, but we want to end up with 2n plus 5 of one of the factors. And so the safe thing to do is to put back the 2n plus 5 first, and then observe what we need to factorize out of the negative 8n here to end up with 2n in the bracket here, and that would be negative 4. Right? And so the negative 4 would be what we have to factorize out of negative 8n to end up with 2n in the bracket. And we can test this factorization by multiplying this negative 4 by this positive 5, which will be equal to negative 20, and therefore the factorization so far is correct. And so this 2n plus 5 becomes a common factor for the next step. And to factorize completely now, we factorize this term using 2n plus 5 as a common factor, and so we end up with n minus 4 as the other factor. And so we have factorized this quadratic expression completely by attaining these 2 linear factors. And that's the end of part 2. Let's move down now to part C of question 2. Now part C tells us of a store that packages lollipops and toffees for sale. And we are told that the mass of 1 lollipop is x grams, the mass of 1 toffee is y grams, and that the total mass of 5 lollipops and 12 toffees is 61 grams, and that the total mass of 10 lollipops and 13 toffees is 89 grams. And we are required in part 1 to write 2 equations to represent the information above. And so this is it. Each lollipop here measures x grams, and each toffee here measures y gram. The total of 5 lollipops and 12 toffees is 61 grams, and therefore 5x plus 12y is equal to 61, and that would be our first equation in x and y. And in the second case, 10 lollipops and 13 toffees measure 89 grams, and each of the lollipops here is x grams, and each of the toffees here again is y gram, and so 10x plus 13y would be equal to 89. And so that's our second equation. So those are the 2 equations that we will get from that information. let's move down to part 2. In part 2, we're asked to calculate the mass of one lollipop and the mass of one toffee. Now, X is the mass of one lollipop and Y is the mass of one toffee. So basically, we are searching for X and Y. And to find X and Y, we therefore have to solve these two equations in X and Y simultaneously. Since we have two unknowns, X and Y, we need two equations in X and Y to solve for those two unknowns. And these are our two equations. So basically, we want to be solving these two equations simultaneously. So let's refer to them as equation 1 and equation 2. And we're going to apply the method of elimination to solve these two equations simultaneously. And in this case, I'm going to simply eliminate the x terms by multiplying this first equation by 2. So we can raise the 5x here to 10x, and then we can proceed by subtracting the two equations to eliminate the term in x. And this is it. We are multiplying equation 1 by 2, and when we do that, equation 1 becomes 10x plus 24y equals 122. When we multiply equation 1 by 2, we have to remember to multiply each term by 2. So 5x multiplied by 2 is 10x here. This 12y multiplied by 2 is 24y, and 61 multiplied by 2 is 122. So this equation 1 and this equation 1 basically is the same equation, and now we are solving equation 1 with equation 2 simultaneously. And so now, to eliminate the x from these two equations, we simply subtract equation 2 from equation 1, and that's our next step. We are going to subtract equation 2 from equation 1. So it's this equation minus this equation, and this is the result of that subtraction. 10x eliminates the term in x, and 24y minus 13y leaves us with 11y on this side, and then on this side of the equation, 122 minus 89 is 33, and so we end up with 11y equals 33. And so to find y, we simply divide both sides by 11, and the result here is that y is equal to 3. And now we need to find the x value to go with this y value, and we can find that x value by substituting in any one of these three equations. And let's choose equation 1 for this next step. So we're going to substitute the y equals 3 into equation 1 so we can find the x value from equation 1. And by doing that, it becomes 5x plus 12y, y is 3, so it becomes 12 multiplied by 3 here equals 61 from here. And so this reduces to 5x plus 36, because 12 multiplied by 3 is 36 here, and we have 61 remaining on this side. And now we want to find x. We can subtract 36, and we end up with 61 minus 36 on this side after we subtract 36, and then we can divide by the 5, and so it reduces to x equals 61 minus 36 on the numerator divided by 5. What it is that we have subtracted 36 on this side, and then we have divided by the 5, and so 61 minus 36 on the numerator is 25, and we are dividing that 25 by the 5 on the denominator here, and 25 divided by 5 is 5, and so x is equal to 5. And so we now can write the solution in terms of the mass of lollipops being x gram, that is 5 grams because x is 5, and the mass of one toffee, which is y gram, is actually 3 grams because, as we said, y is equal to 3. And so that's the answer for this part of question 2, and we'll do our next question, question 3, in our next video. See you then.